Now, the other day, what we did was we found out the equivalent resistance. Okay. And after that, we found out what is IRMS. Do you know what is IRMS? What do you mean by IRMS?
Root mean square.
Root of mean square. Why do we do root of mean square? RMS is root of mean of square. Okay. What do you mean by why do you do root mean square? Because in AC, the current is not fixed. It is keeps changing. Im sine omega t. Okay. And what is the power? What is power through resistance? What is the power?
Power equal to voltage into the
Voltage into current
VN.
or I squared R. Okay. Correct?
Correct.
So it is actually Im squared sine squared omega t into R. Okay. Now this is not going to be fixed. It's going to change. For at different times, it will be different value. At one time, it will be Im squared, and another time it will be 0, and another time it will be Im squared by 2. Because sine omega t keeps changing, so if you plot it, it will not have a fixed value, it will have a varying value. Okay. So you want to find what is the average power, because every time power is changing, power dissipated in the resistance is changing. So if you want to find out what is the power means, you will take the average power. Average power means it is repeating every time period. This is one full time period. Because I squared I'm taking, it is always positive. So this is one time period. From 0 to t, if I integrate it, I'll get the total power into this time. And if I divide by time, I'll get the average power. Did you understand?
Yes, sir.
So average power will be actually average power will be, I will have to add everything for the entire time period. So from 0 to t, Im squared sine squared omega t r dt. Okay.
Yes, sir.
Now I take the average. If I have to take the average, I have to instead of addition, I'm integrating, and I have to divide it by the total.
Im and R will come out.
Okay, Im squared and R will come out. I divide it by t. Okay, correct.
So why, sir, you going to the
Average. See, this is one value. This is another 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 value. All these values I add. So adding is, so if there are 5 numbers, let's say 1, 2, 3, 4, 5, what will you do? Well, I tell you what is the average mark. What will you do?
I will add everything divided by the number of divided by 5.
Divide 1, 2 plus 3, 1 plus 2 plus 3 plus 4 plus 5 by 5. Okay. Similarly here, from 0 to t, you are adding everything. Adding means integrating. You are integrating from 0 to t, and then you are dividing by t. Then you will get the average power. Okay.
Yes, sir.
You will get the average power. So what is Im? The Im squared, I bring it out. R I bring it out. By t, I bring it out. So this is going to be integral 0 to t sine squared omega t dt. What is integral sine squared omega t dt?
Sir, we have to change the sine square into 1 minus cos.
So it is actually
1 minus.
Im squared r by t. This can be written as 1 minus
Cos 2
cos
omega.
2 omega t by 2 dt. Okay.
Yes, sir.
So this, if you integrate it, what will you get? Im squared r by t integral 0 to t 1 by 2 dt minus Im squared r by t integral cos 2 omega t dt by 2 0 to t. So integral of 1 by 2 is what?
T by 2.
T by 2. And if you put the limits, it will be Im squared r into t by 2 by t. Okay.
Yes, sir.
This if I integrate, what I will get? Cos 2t.
So that sine omega t by
Sine 2
2 omega.
omega t by 2 is already there. 2 and 2 omega will be there. And I have to put limit 0 and t. What is sine 2 omega? What is omega t? What is omega t?
Frequency. And
Huh?
angular frequency.
So omega is actually 2 pi f. Okay. F is 1 by t. T will get cancelled. This is 2 pi. Omega t is 2 pi. So if I put 2 omega t, it is 4 pi. This is sine 4 pi. What is sine 4 pi?
Sine 4 pi is 0.
0. And what is sine 0?
So 0, sir.
0. Both are 0. So this full term will go. Okay.
Yes, sir. Yes, sir.
So only this term will there. This t and this t will get cancelled. So you will get Im squared r by 2. Okay. You get Im squared r by 2. Okay.
Yes, sir.
Understood?
Yes, sir.
So average power is going to be Im squared r by 2. Okay.
Yes, sir.
Now, instead of writing Im squared r by 2, what we will say is it is something, some Ix squared r. Okay. Okay. I know it's I squared r, so I put it as Ix squared r. So what is Ix squared r? Is squared r is same as Im squared r by 2. So Is squared is equal to Im squared by 2, or Ix is root of this Im by root 2. So this is actually, I am taking the root of, what I did here was, I am taking the average, root of average of square. I'm squaring it. I squared r, I'm squaring. So that is why I find out the root mean squared. If I find the root mean squared, that is the current which will be the effective current for calculating the power. Okay. When I use IRMS, I can simply square it and multiply by R and get the power. That is why IRMS. Okay. Understood?
Yes, sir. Yes, sir.
Clear?
Yes, sir. Yes, sir.
So in this coexist case, it is going, there is a voltage source, sine wave, and there's a diode. After the diode, you have a resistance. And we found out that that resistance is 5 kilo. Okay. And this is 10 sine t. Okay. In this case, what is omega here? Here, what is omega?
Omega is 1.
Omega is 1. Omega is 1. And this is a half-wave rectifier. So positive half cycle, this will conduct. Negative half cycle, it will not conduct. So the output will be actually will have only, or current will flow only in the positive half cycle. So it will, the current waveform will be 10 divided by 5 kilo ohm, that is 2 milliamp. So the peak will be 2 milliamp. Then negative half cycle, there won't be any current. Then it will be like this. So let me call this as IEM. So now root mean square will be root of 1 by t integral 0 to, here what I put?
0 to
Huh?
t.
I have
T,
not
sir.
put t because 0 to t it's not having value. It's having value only to 0 to t by 2.
Okay, sir.
T by 2 to the t, the value is 0. So I put it as the integral 0 to t by 2 im squared sine squared omega t dt. Okay. Now you know that when previously you did that integration, we saw that you get cos 2t by omega t by 2 omega. And
Yes, sir.
if I integrate cos 2 omega t, I'll get sine 2 omega t. And I put the value sine 2 omega t here, t by 2 I put, I'll get 0. 0 I put, I'll get 0. So I'll take only the term with 1. So this will be actually integral 1 by t, integral 0 to t by 2, 1 by 2 dt. This will be the second term, because I did already, the second term I'm neglecting. Okay?
Yes, sir.
Into im squared. Into im squared. Okay? Clear? Is it clear?
Yes, sir. Please.
So now I integrate this. I get im squared t by 2 by 2 1 by t. Root of this. Okay? This t and this t will get cancelled. You'll get im squared by 4. Root of im squared by 4 is im by 2. So the half-wave rectifier IRMS is im by 2. If you have the full wave, if you have full wave, that is, if it is like this, then it is im by root 2. If it is only half, it is im by 2. I just want you to know this. So im is in this case 2 milliamp. Im is in this case 10 by 5 kilo ohm, which is 2 milliamp. And im by 2 is going to be 1 milliamp. So IRMS in this case is 1 milliamp. In this question, what is IRMS in milliamp through the diode is 1. Okay? Clear?
Yes, sir. Yes, sir.
Okay. Now let us do this problem. In the circuit shown, the voltage Vx is there. So what is the voltage Vx? So this is if you have something like this, that means it is a dependent source. Means you cannot remove it. Anytime you will not
Yes,
remove
sir.
it, you should always keep it. Whether you remove any source, dependent source you cannot remove, it should always be there. Okay, this is a dependent source, this is
Yes,
also a dependent source. This is a dependent voltage source, this is a dependent current source. Now, both are dependent on this Vx. Okay, now let us assume this is 0. Let us assume this is 0. What is this voltage?
sir. Sir, current source we cannot say the voltage. So
No, here this voltage is Vx, right? Let's say this is some V. V minus 0 is what? V minus 0 is Vx.
V,
Already
sir.
this
V,
is
sir.
Vx. Huh?
Okay, sir. Yes, sir.
So I can write this as Vx.
Vx.
this is 0, this voltage is Vx, means I can write this as Vx. Correct?
Yes, sir. Yes, sir.
And you see here, this is 0. That means what is this?
Zero, sir.
0. And what is this?
Sir, 0.25x.
Vx. 0.25 Vx. And what is this?
Same 0.25x.
0.25 Vx. That's all. The Vx, this Vx, this 0.25 Vx, and we can find out the node analysis. Now at this node, you tell me the equation.
Sir, but sir, doubt, sir.
Hmm.
Sir, at 8 ohm resistance, how come the node voltage be 0.25 Vx, sir? Because there is a current source coming in, sir. 0.5 Vx.
Wait 1 minute. I'll just see. I'll draw. I'll see. This is 0. I'm assuming this is 0. Okay.
Sir.
Then what is this?
Vx.
That is clear.
Yes, sir. Yes, sir.
If this is 0, what is this?
That, yes, sir. This is also zero.
This is 0. What is this?
Same 0, sir.
What is this?
0.25 Vx.
What is this?
It will come, sir, but I can't say, sir, because there
This
is,
and this are same. There's nothing in between.
sir, but at the top there is
That
incoming current 0.
But see, this if this voltage is something, if this voltage is
Yes,
X,
sir.
this cannot be anything other than X. This will also be X.
Yes, sir.
Okay. Huh?
So there is nothing to do with this incoming current source 0.5 Vx, sir.
Incoming current source will get adjusted. If this is 0.25 Vx, this is 0.25 Vx.
Okay, sir. Yes, sir.
Okay. So this is also 0.25 Vx. Now at this node, you tell me the equation.
Sir, at node 2 ohm resistor, sir.
Where is 2 ohm? 20 ohm.
So 20 ohm, sir. Yes, sir.
So tell me the equation.
Vx minus 0
Hmm.
divided by 20
Then
minus 5 Vx minus 0.25 Vx.
why minus? It's going out of this point, no?
Sir, no, sir. I'm saying that Vx minus
Oh,
0.25 Vx,
okay,
sir,
okay, okay. Okay.
across 10 ohm
Plus Vx minus 0.25 Vx by
divided by 10
10.
by 10.
Huh?
That's all, sir. Equal
So
to 0.
this you have done, this you have done, this you have done, this.
So there also the same voltage, sir, Vx.
This was Vx means this is also Vx. And there's nothing, it's a current only, no? Why you are worried about
So it is
voltage?
plus
Ah.
0.5 Vx.
All the currents you have to add. This point are same. So this current, this current, this current, this current.
Yes, sir.
Okay. Huh?
Yes, sir. Yes, sir.
So tell me.
So
Vx
multiplying by 10.
multiply by 20.
Okay, sir.
Vx
Vx
minus 100 plus 2 Vx
plus 2Vx
minus 0.5 Vx.
yes, sir.
10 into 0.5 is 5. 20 into 0.5 is 10. Okay. So 10 plus 2, 12. plus 1, 30 minus 0.5, 12.5. 12.5 Vx is equal to 100. So Vx is equal to 100 by 12.5, which is 8 volts. So Vx is 8.
Yes, sir.
Okay.
Okay, sir.
Now do using mesh analysis.
Yes, sir.
Can you use mesh analysis?
Sir, but using mesh analysis, we need a voltage, sir.
Let us assume. Let us assume.
Sir, can we take this?
We will see, like we are assuming voltage here, we will assume current. For mesh analysis, you should assume current. Wherever you don't know, one place you assume. Now, here you assume. Let us say this current 5 amps is coming here. 5 amps is coming here. Out of which 0.5 Vx is going here. So you don't know the one. Let us assume this as I. Huh?
Yes, sir.
So what is this current? Tell me. What is this current? This current is moving out of this point. That means all the currents coming into the point you have to add, that is equivalent to this current. This current is all the currents coming into this point. How many currents are there? There's one current here, there's one current here, there's one current here. Okay.
Yes, sir.
So
Sir,
what is
4.5 Vx minus I.
What is it?
4.5 Vx minus I.
Why 4.5?
Sir, because 0.5 Vx current is going up
Okay.
and
So it is minus 0.5 Vx. Okay.
plus
5.
then
Then this I have assumed as I'm assuming.
minus I.
Minus I. Is this current? Okay.
Yes, sir.
So that into 20. That into 20 is this drop. 5 minus 0.5 Vx minus I into 20 is this drop. Okay.
Yes, sir.
Agreed. And what is this drop? 10 ohm.
At 10 ohm.
Plus minus. I assumed it as I. So 10 I.
Plus I.
Okay.
Yes, sir.
Then wherever voltage source is there, I'll take that directly. I'll take the voltage. I won't worry about this. So I have a voltage source.
Sir, measurements is little confusing, sir.
Why?
That current assumption current on this.
You assume you assume that you don't know this current, so you assume it is I. Anything you assume, you can assume this current, you can assume this current, you can assume any one. If you assume this current, you can find this current. If you assume this current, you can find this current.
Okay, sir.
Understood?
Yes,
See,
sir.
you want to find mesh analysis, you want to find what is the current. So you will have to assume a current. Understood? What is the confusion?
Yes.
You assume, you just put it as X. And once you assume that, other current you will get. So you assume this as I.
Okay,
So you got this as 5 minus 0.5 I Vx minus I. That into 20 is going to be this potential drop. And 10 into I is going to be the other one. And already you know this voltage. You will, wherever voltage is there, you will take the voltage as it is, 0.25 Vx. Okay, now you write the equation. What is the equation?
Plus 5.
Plus 5 minus 0.5 Vx minus I into 20.
Uh,
What is this drop? What is this drop? What is this drop?
okay, sir.
What is this drop? 10 into current.
Okay, sir. Minus 10, minus 10.
Minus
Minus
10.
10,
I
minus 10.
plus 0.2, then minus 0.2,
Minus
0.25 Vx is equal to 0.
Yes, sir.
Okay,
Yes, sir.
so tell me 5 into, what is 5 into 20? 100. 0.5 into 20, 10. Minus 28. Minus 10, 9. Minus 0.25 Vx equal to 0. Okay,
Yes, sir.
so this is minus 10 Vx minus 2.25 minus 10.25 Vx minus 30I
Yes, sir.
plus 100 equal to 0. This is one equation. Okay. Okay.
Yes, sir.
Yes. Now I have what is V. This is also Vx. This is also Vx. The voltage drop across 20 is also Vx. So I can write this, whatever I found out this, equal to Vx. Correct?
That's
So pi minus point. So these three terms together, that is pi minus 0.5 Vx minus I into 20 is also Vx. That means 100 minus 10 Vx minus 20I is equal to Vx, or 100 minus 20I is equal to 11 Vx. Okay. Agreed?
yes, sir.
So one equation is 30. First equation is I am rearranging this equation 30I plus 10.25 Vx. 30I plus 10.25 Vx is equal to 100. Agreed? This is one equation. Okay. Then the other equation is going to be 100 is equal to 11 Vx plus 20I. Okay? Agreed?
Yes, sir.
Now I have to eliminate I. So what I do, I multiply this equation by 2 and this equation by 3. I get, if I multiply this equation by 2, I get 60I. This equation, if I multiply by 3, I get 60I. So then I can subtract. Okay.
Sir.
So this equation I multiply by 3. So 2 into 3, that is, so this will be 60I. First equation will be 60I plus 10.25 into
Plus
2 is,
66.
no, first one.
33 gains.
30 into 2 is 60. 10.25 into 2 is 20.5 Vx is equal to 200. second equation I'm multiplied with 3. So 60I plus 33 Vx is equal to 300. So I subtract the first equation from the second equation. 33 minus 20.5 is 12.5. Is equal to 100. So Vx is 100 by 12.5, which is 80. 8. You got the same answer. Vx is equal to 100 by 12.5, which is 8. I just want to teach you both the methods, and both are getting the same answer. So the answer is 8. Okay.
Yes,
In nodal analysis, you will assume the voltage. In mesh analysis, you assume the current. That's all. Okay.
Okay, sir.
So I don't think we have time for another problem. We have already another 7 minutes are there. Okay, let us try to do it this fast. In the
Yes,
given circuit, the values of V1 and V2 respectively are. Just tell me, this easily you can do by nodal analysis. You assume this voltage. You assume this voltage. For nodal analysis, you will assume voltage. Okay. Don't do it
Yes,
fast.
sir. V minus 0 divided by 4.
V minus 0 by 4. Okay.
Plus V minus no, sir.
Another V minus 0 by 4.
Sir. Minus 5 ampere.
Minus 5. Then
plus I2. Plus 2. Plus 2 equal to 0.
Plus 2I.
Yes, sir.
So multiply by 4. So V
plus
plus
V
minus 20.
4 plus 4I.
Plus 8I.
Yes, sir. Plus 8I equal to
2V plus 8I is equal to 20. Okay. Now
taking 2 common.
So V plus 4I is equal to
V
10.
plus 4.
Okay.
Yes, sir.
Now, what is the relationship between V and I? This is I. This is total. This is I.
Yes, sir.
So, can you tell me what is the relationship between V and I here? V minus 0 by 4 is equal to I.
Yes, sir.
So, V is equal to 4I.
Yes, sir. You can take, sir.
So, this 8I is equal to 10. Okay.
Yes, sir.
So, I is equal to 10 by 8.
Five by 4.
5 by 4. 1.25
amperes.
amperes. Okay.
Yes, sir.
We are asked to find out, you are asked to find out what is V1 and V2. V2 is this voltage. V2 is this voltage. This voltage is V2. This voltage is V1. So V1 is same as V. This is V1.
Yes,
This is V1. This is also V. What is V? 4I. I is 1.25. 5 by 4 into 5. 4 into 5 by 4 is 5. V1 is 5 volt. So V1 is 5 volt. Okay?
Yes, sir.
V1 is 5 volt. And this current, what is this current? V2 minus V1 by 4. V2 minus V by 4 only is this current, right?
Yes, sir. V2.
V2 minus 5 by 4 is this current. What is this current? Is this current?
5 ampere.
5 is equal to 5. So what is V2?
20 minus 5, 15 sir.
20 plus
Sir.
5.
Yes, sir. Yes, sir. 20 plus
So-
25.
So
25
V2 is 25. So the answer is V1 is 5, V2 is 25. V1 is 5, V2 is 25.
Sir, on first we took V minus V2, no, sir. But why now we are taking V2 minus V, sir?
What is that?
Sir, on first we took node V minus V2,
Ah,
but now finding V2, we are taking V2
okay, you take
minus
you take V minus V2. You take V minus V2. V minus V2 by 4 is this current.
Yes, sir.
What is
That
that?
is
This current is 5.
Minus 5.
Minus 5.
Minus 5.
So then I'll do like this. 5 minus V2 by 4 is minus 5. 5 minus V2 is equal to minus 20. So V2 is 5 plus 20, 25.
yes, sir.
If you want to find this current, it is V minus V2. If you want to find this current, it is V2 minus V. Here phi is this current. So I took this minus this.
Yes, sir.
Okay?
Okay, sir.
Okay, thank you. God bless you.
Thank you, sir. Thank you, sir. Yes, sir.
Okay, sir.
Okay. I'm closing it.
Thank you, sir.